So in this last section of Unit 1, we're going to take a look at limits that involve infinity somehow, whether your limit value is infinity or the x of the limit is approaching infinity. So just to define the difference between the two, an infinite limit is a limit that results, meaning your answer is either a positive or negative infinity, whereas the terminology limits at infinity is referring to the x variable approaching positive or negative infinity. So this is when your answer is infinity, but this is when the x is approaching positive or negative infinity. And if you think about it, if x is approaching positive or negative infinity, you're going towards the end of your graph. This is somehow describing your end behavior. Do you go up forever? Do you go down forever? Or maybe you even level off at an asymptote, and we might see that in a little bit. So just to practice the two, I know we've seen kind of some of these so far this year, but now we're actually formally defining them and going to focus on them in this section. Notice how the F graph is given up top here, and if we want to approach 2 from the left, notice how we go down forever because we are approaching that asymptote. If we want to approach 2 from the right, we'd go up forever, so that'd be positive infinity. So these are what are called infinite limits because notice how our answers are positive or negative infinity. On the G graph, we want to approach -1 from the left. Looks like we would go down. And if we approach -1 from the right, looks like we would go up. Now for limits at infinity, we're going to go to the far ends of the graph. For the f of x graph, if we go forever to the right, looks like we would level off at the horizontal asymptote of 2. And if we go forever to the left, looks like we'd level off at 2 again. For g of x, if we go forever to the right, notice how we're not leveling off exactly. Okay, we are approaching an asymptote, but notice how this one is slanted. Okay, it's not specifically horizontal like this one was in the f of x. So if it's slanted and we're going to go forever to the right, notice how we would continue up forever. So this one is actually kind of interesting. This can be classified as both an infinite limit and a limit at infinity, because notice how the x is approaching infinity, but our result or our answer is also infinity. So this is an interesting one which can be classified as both. On g of x, if we go forever to the left, again we are approaching that slanted asymptote. If it's slanted, it has some slope, so we're most likely going to be going down forever to the left. So just as a rule of thumb, kind of the difference between the two, again, not only in their terminology, but depending on which limit we're working with, we're probably either talking about a vertical asymptote or a horizontal one. Notice how if your limit results in infinity as an answer, the x value you were approaching from the left or the right was the location of a vertical asymptote. So these infinite limits help you find vertical asymptotes, okay, where those are located. Limits at infinity, on the other hand, can help you find horizontal asymptotes as long as your result is a number. Notice how these were not numbers, so we did not have a horizontal asymptote on the g of x graph, but since these were numbers for f of x, we did level off specifically somewhere to the left and to the right. So these can help you find those horizontal asymptotes for your end behavior.